In this tutorial, I am going to talk about how to analyze elevation data using QGIS and Grass-GIS. So, first one I am going to explain is how to analyze elevation data and produce these terrain variables like slope, aspect, hillshade, plan curvature, profile curvature, and how to reclassify all these terrain variables. And next part I will tell you about hydrology analysis. In this part I will talk about how to create river network and watershed using the elevation data. So you need to download the data for the region of interest. So in this video you can see how can you download the elevation data, which is freely available, and then as we need more than one DEM, we need to merge them or mosaic and then clip to the region of interest and then reproject it, because our data is in geographic coordinate system, so we need to reproject. So these are the items of our tutorial. So now I will show you how to do it. So I have already downloaded the DEM data for one of the districts of Nepal known as Bhojpur district, and I have also this vector data of the polygon, which is the region of interest. So just I will drag and drop this, and this is my region of interest, and now I will drag and drop these files ending with DEM. So these are the files, and so I will group them. It is not necessary, but I prefer making a group. So DEM, and now I'll show the region of interest above this DEM. So we need to merge all these four DEM. So first of all we use raster and then merge, and there are two ways we can do merging. So one is build virtual raster and another is merge. So I will use this build virtual raster, and input layers we click here and select all, and then you should remember not to check this one, and then other parameters kept as default. Then the virtual raster we save it as a file. For example, I save it in video folder. So the file name is dem all.vrt. So virtual raster data has format extension VRT. So I save it, and then when you run this, it takes few seconds and it is finished. So even if I remove this, you can see this here. So now we will clip this merged raster into new raster data. So there is raster, extraction, and clip raster by mask layer. So if you clip by extend, then it will clip rectangular shape. So we are going to use mask layer, so that outside the mask layer the data will be null or no data. So input data is this DEM all, and mask layer is this region of interest. And then I will keep the no data value, so you can put like this -9999. It is the convention. And then I save this data to a TIFF file, not as virtual raster, but I will save it as TIFF file. And like for example DEM, so it is geographic coordinate system, so I will write DEM GCS.TIFF and then run this one. So if you remove this, then we can see that it is just above this Bhojpur district, so we have clipped it successfully. So but for the elevation analysis we need a metric system, so we will convert this into UTM projection. So we will use Reproject. So in the raster projections there is warp or Reproject, and then we can use source is 4326 and target is my UTM projection is 45N, so I am choosing this one. And resampling method I will choose bilinear. So why I choose bilinear, you can search the references, and if you want to know the difference you can try both this method and see the difference for yourself. So let us choose this bilinear, and again no data value I set -9999, and so other things default. So reprojected raster is saved as DEM UTM, so it is UTM projection, so I save the file as UTM and then run. So now it is converted to UTM projection. So we will start a new project from here, and I don't save it, and now we can check the data which is inside this video, and I have saved it as DEM UTM, so I drag it to the canvas and now it is displayed here, and you can check that the coordinate reference system has changed to UTM. So it depends on the first data we display in the QGIS map canvas. So if you successfully reproject, then it should show the new projection, and also the coordinates should be 6 or 7 digits. So next one we will create some terrain variables. For example, from raster analysis we can create slope. So DEM UTM we are going to use, and slope, in case of slope we can represent it as percentage instead of degrees if you want. So we save this file like slope, and then run this one. So it takes very small time. So we can see that the dark area, these are either river or ridges, and the gray and white area are slope. The slope, higher slope is more bright. So now we check another variable like aspect. So again we choose the DEM UTM, so we should be careful while selecting the input layer, and then we select the output. So in this case we have aspect dot diff, and run this. So if we move it above, so we can see the direction of aspect for each cell. So for better visualization, we reduce the transparency, or we increase the transparency of the aspect. So symbology we use we use transparency and make it like 50%. So in the background we can see the slow elevation, so we need to change the style of this elevation. So let us try to change the symbology. So instead of single band gray, we use single band pseudo color, and we choose this different ramp. So we create a new color ramp from the existing one. So there are many color ramps already available, so we choose one of them. So we can see these color ramps. So let us find a good one. So in the QGIS we can find the elevation, so we can choose this one also. Otherwise we can check here and so we can find this one. Okay, and apply. So we can see a better visual representation. So now next one we create Hillshade. So Hillshade gives a better 3D look of the elevation. So we use this DEM. You can change the azimuth of the light and also altitude. So you need to know what is the meaning of azimuth and altitude. But in this video I am not going to explain this. So let us save this Hillshade as HS, which means Hillshade. So in the same folder I am saving this Hillshade. So now I will remove this aspect and change the Hillshade opacity. So again I put it and apply. So it looks quite good. We can identify the rivers flowing from here to this direction, and from this top of elevation we find the rivers are flowing like this. So this way we can analyze elevation data, and we can find several other things like plant curvature. So we can search here. So in this r.slope.aspect we can create all the terrain variables in a single run, but I am going to tell you about other variables using Grass-GIS. So you have both options, QGIS and Grass-GIS, and if you use both of the softwares you will decide which one is better for you. So I'll close this elevation analysis part, and then next part I'll explain about how to use this elevation data in Grass-GIS. Now I am going to talk about hydrology analysis and a few other elevation related topics using Grass-GIS. So I have created a folder called ELEV Grass, which I will use to create data. So first of all I have also opened this Grass, which shows two different user interfaces, windows. So one is to manage data, layers, tools, etc., and one is to show the map. So first of all I will change the folder directory by using this console. So like you can write in the console cd. So working directory changed to this folder, and now we can use this tool, add existing or create new database. So we can create a new database in this folder. So this folder is added in the list, and we create a new location. So yes, so name of new location is, for example, Bhojpur, and description analysis data, and next. So we read the CRS from a georeference data file, so we click this one, and then next. So we select the georeference file, which is we just created in this folder. So DEM UTM is the georeference data file that we just created few minutes ago, and then next. So we can see that it is using UTM zone 45 with WGS 84. So it asks whether we want to import this newly created data, so we import this. So now we can see that this folder, this Bhojpur is created. So now the current grass database is this. So previously it was the selected and current, but now this is the current database. So DEM UTM is here. So if you double click this, the map will be displayed here. So let us do some analysis. So in this tutorial we will again create the slope aspect, hillshade, etc. So if you click here r dot slope dot aspect, enter, and again enter, then we can see this tool. So what are the outputs we are going to do? So slope, we create slope, we create aspect, we create profile curvature, and we create tan curve, which is probably plan curvature, and we skip others. So when we run this, and we can see that this is the command. So we can copy this command, but we can see that elevation we have not yet selected, so it is required. So name of the required elevation map is DEM UTM. So DEM UTM is selected. Now if we copy this command, then we can run from here. So what is benefit of using this is you can do it multiple times. So if we enter, then it creates all the terrain variables, and if you click the up arrow, we can display the same command here. So this is one of the feature that I like about Grass-GIS. So let us see when it completes, then we will start another part. So we can also create our shaded relief, which is same as hillshade. So let us wait while it is doing. So r dot relief, let us see how it does. R dot relief and run. So we can see the manual, what it does. So our output is completed here, and in the meantime we can see this hillshade and the r dot relief are similar thing. So we can copy many things from this manual also. So let us use r.relief, and required map is elevation map. So elevation is here, and shaded relief we can say HS again, and then run from here. So sun position also we can decide, like 45 degree, and this like 135 degree, and run this one. So there are both options. We can run from the console, or we can run from this user interface. So even after running this, we can press the up arrow and see that what are the parameters we used in our last tool. So this is the benefit of using Grass-GIS. So Hillshade is at the top, so we can change opacity level here also, so like 50, so we can see the tan curvature beneath, or profile curvature, or aspect, or slope, or the DEM. Now I will tell you how to reclassify the raster. So there are many purposes of reclassification, so I am not going into detail. So for example, we want to classify the elevation or slope. So for example, steep slope and mild slope, so that way we can classify. So what is the range? So I have, it is it should be slope rule, but by mistake I have created elevation rule. So 0 to 15 degree slope will be classified as 1, and 15 to 30 as 2, 30 to 45 as 3, and steepest slope will have value 4. So we are going to use this classification rule to classify the slope. So let us try this console, and I make it bigger. So r dot, there is a tool called recode, so we will use this recode. And so name of the raster map is slope map, so we have already displayed the slope map. And output, for example, reclass dot slope. So recode rule, as I already showed you, so this is elevation ELEV rule dot text. So this should be the format. So 0 to 15 converted to 1. So we separate by a column. So with these 3 input parameters and run, then we can create a classified slope. So we can see this slope classified into 4 types, and in the same way we classify this aspect. So I will show you why we classify aspect, because aspect is from 0 to 360 degree. So we classify it into north, northeast, east, southeast, in this way. So in case of grass, it is the degree is calculated from east and in anti-clockwise direction. So east direction starts from minus 22.5 to plus 22.5, and northeast 22.5 to 67.5. So I have created this rule also. So 0.0 to 25.22.5 will be 1, and so on, and finally the last 337.5 to 360 will again be 1. So 1 will be east direction and 2 will be northeast, and so on. So let us use this rule, and same way we can classify this aspect. So from the console, so we can just press the upward key and change the parameters like aspect and reclass dot aspect, and the rule I have created is in ASP rule. So if everything is okay, then just press enter and the aspect will be classified into north, northeast, east, in that way. So we can see the aspect, the classified aspect looks similar to the aspect, and this is the end of reclassification part. So now what we do is we try to analyze the watershed. So we use r dot watershed and check what are the parameters we need. So we use elevation raster and so we can create some outputs like flow accumulation, and this is flow direction. So this is basin, and this is stream, so these are the things we are going to do. So we can choose other parameters from here. So you can also choose the threshold of the watershed to create watershed basin. So let us run this one. So option basin requires threshold. So we need to choose the threshold. So let us say 1500 and try to run this. So now it is run. so it will take a few seconds. So this is complete, so we can see the basins here and layers. So stream is not visible, so why it is not visible I will show you. And we can see the basins, flow directions and flow accumulation map. So in the flow accumulation map we can see the dark blue area where the water is flowing, which has higher flow. So if we remove this one and show this, then we can see the stream. So now we are going to create river as vector data. So from the console we can use r.stream.extract. So when you find the proper tool, then just press enter, then it will be selected. So in this case we will again use DEM. So for the stream, so let us say 5000 number of cells to create a stream. So input maps, so accumulation raster we should use the flow accumulation raster which we just created. So we don't have any depression. So output, so name for stream raster we create like stream 2, and vector we use river. So you can choose the name as you want. So flow direction we may skip. So now if we run, we can now create this river and stream raster, or we can also skip this. So let us say so we can see that rivers are created here. Now next thing I will tell you how to create a watershed for a given outlet point. So if you want to change the threshold for the river, just press up arrow and change this like 10,000 and then overwrite, because we have produced the already produced and we need to overwrite. So if you run this, the river will be changed, and only the rivers will be created when the threshold is above 10,000 cells. So next we are going to create watershed for a given output point. So we should select a point very precisely so that we can find the watershed. So let us check. So we can choose some point like the river flow point. So let us check here and copy coordinates to clipboard. So let us paste here for some time, and we can reduce the rounding decimals, and then we can just make it 70.00, and then close this one, and then click r.water.outlet and run this one. So input drainage direction map, we have already flow dir we have created, and watershed basin, like for example WS selected. So coordinate of output point we can copy from here, and then others are optional. So we create this WS cell and run. In this tool, we create the output as raster. So if we want to convert it into vector, so we can use a different command. So but this is not created properly. We can see that it has very small watershed. So let us try a different one, which is just at the junction. So this junction, let us try once again. So we change the coordinates from here. So right click here, and again we paste here, and then we need to overwrite and run again. So we can now see the big area of the watershed. So this is the area of watershed from the where water is coming up to this point. So we need to convert it to vector polygon for further analysis. So r.to vector vect, and now we can use this watershed basin. So WSSEL and vector map. So for example, we put basin, and output feature type we create polygon. So when we run this, so now we have created polygon vector data. So this is the end of this tutorial.